Alright, welcome back. Well, we're going to look at part 2 of this IP version for subnetting, which is specifically looking at subnetting for a specific number of hosts. Now, we previously in part 1 looked at a basic overview, and we're going to touch on that quickly again, basically the default class A, B, and C, because your first step, pretty much whenever you do subnetting, is to determine what the default subnet mask is, especially if it's not given to you, because that's always your first step, what you need to look at. Because remember, when subnetting, you're always adding bits to the existing subnet mask, and if you don't know what the existing subnet mask is, you're kind of stuck. Now, with a class A address space, again, the first octet with a class A address space is always going to equal 1 through 126. That defines it as a class A. The default mask, 255,000. Class B, your first octet, is always going to equal 128 through 191 with a default mask of 255,255,000. Class C, your first octet, is going to be 192 through 223 with a default mask of 255,255,255,000. Now, quickly out of the way, if we take a look at a specific example here, just sort of jump right into things. Say that I have a subnet and I want to have at least 50 hosts per network, and the network ID that I'm starting with here is 192.168.10.0. Right, now again, the first thing we need to know, because we're subnetting, is what is the default subnet mask? Well, being that a 192 is a class C address space, my default subnet mask is going to be 255.255.255.0. So this is going to be my starting point. Now, there are a lot of calculators out there that you can use to figure this out. It's always a nice idea, though, on how to do this roughly in your head. Feel free to use a calculator to verify what you receive, but it's a really good idea to understand the mechanics of this way if you ever need to really do it. So, when we start taking a look at these options here, first off, when we take a look at my default subnet mask in binary rather than decimal, we know that it's 255.255.255.0, right? But here it is in binary, so just a big long string of ones, which would be 255.255.255.0. And specifically, if I take a look at the decimal and binary representations of the bits that I have the ability of playing with, the bits that are already marked as part of my subnet, I can't touch those because I'm adding bits to the subnet mask, not taking them away. So consider them locked in place. You're not going to touch them. But anything that's not a 1 with my default subnet mask, in this case a 0, I have the ability of adjusting them, making them 1s, and seeing however many I need. Now, when I take a look at the decimal representation of these, which we did briefly again in the last video, 1, 2, 4, 8, 16, 32, 64, 128, you add up all those, you get 255. Now, what we're going to want to do here, though, is because I'm looking for specifically 50 hosts per network. Now, looking at the decimal representation of these bits, the 128 down to the 1, what I want to do is figure out, well, what equals 50? What can I mark off here? What can I add up to give me the number that I'm looking for here, which in this case is 50? And if I look at this, if I add the 32, the 16, and the 2, that gives me 50 specifically. 32 plus 16 plus 2 equals 50, the number of hosts that I'm actually looking to find on this network. Now, what this tells me is the number of bits that I need to reserve for hosts specifically. And the total number of 1s and 0s here that equal the number 50 is 1, 2, 3, 4, 5, 6. So I need 6 bits remaining for hosts to allow me to have at least 50 hosts per network. Now, a lot of times you're going to get more than 50. You're not always going to get the exact thing you're looking for, but I need a bare minimum of 50. And 6 bits reserved for my hosts will give me that. Now, when you look at a subnet mask in binary, there's only 2 types of bits. It's a 1 and a 0. 1s are your subnet bits, 0s are your host bits. And when I'm saying that I need 6 bits reserved for host, that means I only need 6 zeros. Currently, I have 8 zeros, which means 2 of them can be converted to 1s to support my subnet mask. So my new subnet mask is going to be 24 1s, all the original ones, plus an extra 2. Now these 2 here at the end, where we're extending the subnet mask, these are the ones that we just added, because I said that again that I needed 6 bits to reserve for hosts, so I keep 6 zeros at the end, and everything else gets converted over to a 1, which gives me this wonderful big long string of 1s. Now, of course, I need to figure out what this equals. So, if we take a look at this, all 8 ones, that's easy. It's always 255. So we got 255, 255, 255, something. We need to figure this one out. And again, I can use the little decimal breakout, decimal to binary conversion that we looked at previously. Just mark down the 8 bits, specifically 128 down to the 1, and we're using the first 2 in this octet. So in other words, these two right here, the 128 and the 64. When you add up 128 and 64, you get 192. So my new subnet mask is going to be 255.255.255.192. Now, there's another way that Microsoft's been adopting in the past few years of representing a subnet mask rather than just writing it all out of 255.255.255.192. A lot of times now, you're going to see slash notation, where it's just a slash and then a number. Now, what this is, specifically here in this case, slash 26, that's the same thing as saying that you have a subnet mask of 255.255.255.192, because this is saying you've got 26 bits in your subnet mask, and that's exactly what we have here. I've got 8 bits, 8 bits, 8 bits, which would give me 24 of the default subnet mask, plus the extra 2 that I added in to give me the 192, which would give me 26 bits total. It's a lot easier to write out the slash 26 than it is to write out this big 255.255.255.192. So Microsoft now, a lot of times will just put in the slash, be it 24, 25, 26, whatever it is at that point, rather than writing out the entire subnet mask. So just be aware that that slash notation is there to represent what exactly is the subnet mask. Now that we have the subnet mask, that's great. That's step 1 of figuring out what we need. And my new subnet mask, again, is 255.255.255.192. But now I need to figure out what the new networks are that subnet mask defines. Because, again, your subnet mask defines the different network IDs and the hosts that live on those networks. To do this, take the number 256. Now, this number is everything in an octet, 0 up to the number 255 that you have as an option. You have 256 total options available to you, and subtract the number we just found out for my subnet mask, which in this case is 192. So 256 minus 192 gives me 64. This is the number that new network IDs are going to increment by, and we'll see that in a second. So the new network IDs that 192 as a subnet mask is going to provide me is 192.168.10.0. That's initially the first one that we started with. The next one is 192.168.10.64, 10.128, 10.192. You can see it's that 4th octet where the 192 came from that's incrementing by 64s. Now, these addresses here are now network IDs. These are not IP addresses that you can assign to a host or a device on the network. These define different networks when you use the 255.255.255.192 subnet mask. After we have the network IDs figured out, then we need to figure out what exactly are the valid ranges of addresses on each of those networks. And to do that, very simple mathematical deal. Again, my first network ID was 192.168.10.0. The next one was 192.168.10.64. To figure out the valid range of addresses on the 10.0 network, we do a +1 to the original network ID, 10.0, and a -2 to the next network ID, which is 10.64. Now the reason we do the +1 is, again, 192.168.10.0 is a network ID. I can't assign this to a host or a device, so we add 1 to it, which is the first available IP address. In this case, 192.168.10.1. We subtract 2 from the 64 because, again, 64 is a network ID and I can't assign it to a host. And the very last address in each range, in this case 63, is known as the broadcast address. Now, if we were doing subnetting for Cisco or more detailed information, we'd look more into that. But for Microsoft specific exam-based subnetting, it's really not important. It's just that we can't use the .63, in this case, the very last IP address in each network, to assign to a host, which is why we -2. So we get a valid range of addresses of 10.1 through 10.62 on the 10.0 network. When I take a look at the 64 network, which is the next available network, I'm going to do a +1 to the 64 and a -2 to the 128 network, the next available network ID, which gives me an address range of 65 to 126. The next one, 128, would give me an IP address range of 129, one above the 128, through 190 when I take the 192 -2. So you should be seeing a pattern here at this point. And a lot of times, subnetting is one of those things where you just need to have a bit of repetition to it because all the steps are essentially the same. You just need to keep at it. So if you take a look at another one here, just again to try to hammer some of the steps home, again, I'm going to start out with the same network ID, 192.168.10.0, but instead of 50 hosts on the network, I want 22 hosts per network. So again, 192 is a standard Class C IP address, or Class C IP address at this point, which is going to give me a default mask of 255.255.255.0. When I take a look at this, again, my default subnet mask in binary, bunch of ones, 8 zeros at the end. These are the ones that I can play with, and here's their decimal representation, 128 down to the 1. I need to figure out a subnet mask to give me at least 22 hosts on this network. So what this is going to provide me is, again, I want to add up the options from 128 down to 1 that's going to equal 22. 16, 4, and 2 in this case is going to give me exactly what I want. 16, 4, and 2 give me 22, which is the number of hosts that I need. Now this means that I've got 1, 2, 3, 4, 5 bits that I need to reserve for hosts of my 8 total bits that I'm currently using. Which means if I'm reserving 5, what happens to the other 3? They get added to my subnet mask, which is going to have now a subnet mask of 8 bits here, 8 bits here, 8 bits in the third octet, and then 3 bits in the fourth octet, with those 5 zeros at the end representing my 22 hosts. So again, what does that 3 bits at the end equal? We've got 255, 255, 255, something. So again, use that decimal to binary conversion option to the 128 down to the 1. Mark off the 3 first bits, because those are the ones we're looking at here. So the 128, 64, and 32, add them up, you get 224. So my new subnet mask is 255, 255, 255, 224, or, again, if you wanted to, represent it as a /27, because I have 8 bits in the first octet, 8 bits in the second octet, 8 bits in the third octet, and 3 bits in the fourth. 8 plus 8 plus 8 plus 3 is going to give me /27. Now, when I want to figure out the new network IDs and ranges of addresses, again, take the number 256 and subtract 224, the number that I figured out, the oddball number I figured out in my subnet mask, gives me a number of 32. So now my network IDs are incrementing by 32s. So my network IDs that I'm looking at now, 192.168.10.0, 10.32, 10.64, and 10.96. There will be more than this, it's just I don't want to list out every single available one. It's a big repeating pattern once you really start looking into it. The ranges of addresses, again, we do the +1 -2. So for the 10.0 network, we do a +1, which gives me the first valid range of 10.1. The next available network ID in this case is .32. We do a -2, which gives me a last available address of 10.30. Looking at the next range, the .32 network, we do a +1, which gives me a first valid address of 10.33. My next network ID of 64, we do a -2, which gives me a last available address of 10.62. On the 64 network, again, we do a +1 to the 64 network ID, which would give me a first available address of 10.65. My next network ID of 10.96, subtract 2 from it, which gives me a last available address of this range of 10.94. Hopefully you're seeing a bit of repetition here. Again, there's a lot of options where it's just really just getting the steps down to make sense. Now, in the third example here, we're going to step it up a little bit and look at a Class B address space. So 171.109, default Class B subnet mask 255.255.0.0. Now the big difference here is the total number of bits that we have to play with. Previously, with Class C, we only had 8 bits we could play with per host, which gave me a total of about 254 hosts that I could really break down. Now, I've got 16 bits that I can play with, which gives me over 65,000 available addresses. Much larger networks, in this case, are available to me. So I can have subnets with multiple thousands of hosts on it, not just 25 or 50 as we saw previously. So when I want to figure something out here, I got to figure out exactly what I need. So now what I want is a network with 1,500 available hosts. All right. So when we start taking a look at this, again, we're going to break this down into decimal binary conversion, but I need more than 8 bits to represent 1500, because when you add up all 8 bits, you only get 255, which isn't close to what I need. So I need to extend this out to more than just the 8 bits in one octet. And what you'll see, just like in a single octet, the bits just keep doubling as you start extending them. So you get 256, 512, 1024, 2048. And the same options apply. I just need to add up the bits necessary to give me the number 1500 that I'm looking for here. And to do this, if we take a look at it, adding up the 1024, 256, 128, 64, 16, 8, 4, and 2 will give me exactly what I'm looking for, the number 1500. Now this means, at this point, that we're using 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 bits that I'm going to be reserving for my hosts. Everything else is going to be swapped over to the subnet mask. Which means my subnet mask, when I look at it, is going to have 8 bits in the first, 8 bits in the second, because those are your default Class B address range. But I'm reserving 11 bits for my hosts, and my hosts are always the zeros at the end. So I've got 8 bits in the last octet, and then 3 bits in the third octet, which is going to give me my total of 11 bits that I'm reserving for hosts. Everything that I'm not reserving for hosts is going to be swapped over to ones and added to my subnet mask. So I had 16 bits total for hosts that I could play with. I only need 11, which means 5 bits are then going to be added to my subnet mask to give me my new subnet mask that I'm using. When I take a look at these 5 bits and break them down, the 128, the 64, the 32, the 16, and the 8, these 5 bits here, you'll see when you add them up, you get a total of 248. Which means my new subnet mask is 255.255.248.0, or, again, if you want to look at it, a /21, because we had 8 bits here, 8 bits here, 5 bits here for my subnet mask, so 8 plus 8 plus 5 would give me a total of /21, which would be the same thing for representing my subnet. Now, in this case, figuring out the network IDs, very similar, slight difference. So again, we're going to take 256 and I'm going to subtract the oddball number in my subnet mask, which what we figured out was 248, which gives me the number 8. Right? So this is again what my network IDs are incrementing by. But this 248 came from the third octet. Right? So it's the third octet that's incrementing by 8. So my first network ID is 171.109.0.0. The next one, 171.109.8.0, 16.0, 24.0, 32, 40, 48, so on and so forth. Right? So it's not the fourth octet we're dealing with here, it's now the third octet. When I start looking at the valid ranges of addresses, this is also where it starts to change a little bit. My first network ID, 171.109.0.0. My next network ID, 171.109.8.0. Now again, we're doing +1 minus 2, but that +1 minus 2 is always done on the very last octet. So my very first available address is 171.109.0.1, because that's the first address after 171.109.0.0. Then my last available address as the 8.0 minus 2. So basically count back 2 addresses from 8.0. The address right before 8.0 is 7.255. And again, the very last address in every range is the broadcast address. I can't assign that to a host. So the last available address would be 7.254. Right? That's where the minus 2 comes in. 8.0 is 1, 7.255 is 2, which gives me 7.254 as the last available address in this range. When we look at the next address range, the 8.0 is the first network ID we're dealing with. This is the one we want to figure out for. 16.0 would be the next network ID, so that's my top end. So we do the +1, which gives me again the first available address, 171.109.8.1, the very first available address, and then count back 2 from 16.0. So the broadcast address here would be 15.255. The last available address would be 15.254. And everything in between 8.1 and 15.254 will be a valid address on this range. The next option, 16.0 network. So the IP address available range here, again, 16.1, the very first available address after the network ID of 16.0. 24.0 is my next network ID. If you count back 2, 23.255 would be the broadcast, which leaves me with 23.254 being the last available address in that range. So As you can see, especially from these Class B ones, you might notice something here. The only thing that really changes here is the third octet, 0 through 7 for the 0 network, 8 through 15 for the 8.0 network, 16.23 for the 16 network. The fourth octets are all the same, 1 to 254, 1 to 254, and 1 to 254. Subnetting, I can't say it enough, is a lot of repetition. It's just getting the steps down to make sure that you understand what you're looking at, and you sort of have an idea of anticipating what you're going to see at the end. Anything that doesn't look right, go back and check it. So again, this is just a basic overview. Gives you some of the steps to get this done without using calculators or utilities in the background. Part 3 is going to be subnetting for networks, which you're going to see is extremely similar as subnetting for hosts. It's just switching one little thing around, so it'll actually hammer a few things home again. So hope to see you in step 3, and I'll talk to you in a bit.